So it's clear here it is rotation 90 degree. So it's the rotation. Degree. Okay, this is one mark and 90 degree is another mark. So, and the last mark, it will be around which point? And around point in the 90 degree or the rotational itself, you have to get it by this way. First of all, you have to make a, here we have 2 points. Can you see that? This, okay, let's start from this point, the top of the triangle, and another this point. I have to extend it to make a 90 degree. I'll see at which point they are intersect the 3 points. Okay, so exactly we have to make it, and the best way is to set it with your set square. Okay, so here it's clear that is here 90 degree. We'll have to go to another point. Let's take this point, for example. The right angle point, this point, okay. And take this. And this one. And you're going to measure them with a 90 degree lines, how we can reach from A to B with a 90 degree. So you can reach it by this way, connected. The last one, which is extend to the first here. So it would be also like this and this. So it's clear that is around the point, this one to this one. So it's clear around the point 1, 2, and 1, 2. It's here 1 in the x-axis and 2 in the y-axis. So around 1, 2. And it is. Okay, reflect triangle A on the line x equal to 2. Okay, let's erase all these points because we're ready to make it. So when you say x equal to 2, we have to make a straight line like this. At x equal to 2, and you're going to reflect it like this. So that is 4 centimeters here. And another one down like this. And the last one will be like this. Okay, and here say it, label it C. So here say this is triangular C. Did it, okay, then translate it. Translate triangle A using vector 4, 6. For sure, 4, this is for x, and 6 is for y. X is for the right, and y is for up, because no negative signs. So we're going to take A and move it here. 4, 1, 2, 3, 4, and 1, 2, 3, 4, 5, and 6. Okay, so we have to start our triangle here. I'm going to draw it clearly as it is. So here we have 4 centimeter like this, and getting down. Is this to get down? Okay, getting down for 2 centimeter, and then join it like this. Okay, everything with your ruler. And we did it. So we have a point of 5, 1, and 5, 3, and 1, 3. That is the plotting points. Okay. You don't have to write it, but you have to check it. Yeah. Next. Here we have statics. So the frequency quality show the numbers of hours sunshine each in February and July. Different. February is about end of winter and July is in the summer. So the numbers for sure in the summer will be greater than in the winter here. Okay, so numbers of hours here, it will be H, and numbers of days, it will be, this is the number of days. Okay, find the numbers of days where there are 3 or more, remember, and focus with the words or more. Yeah, 3 or more. Okay. Okay, 3 or more. So hours of sunshine each day in February. Okay, so that is 3. Let's move to 3 hours. That is for 3 hours. We are going to moving to February. It will be like this. So it is 6 days or more, another 7 days. So here I'm going to say 6 plus 7, which equal to 13. Complete the model with the most repeated in February. Okay, let's write this. The most repeated, and he needed in H. The most repeated, so the most repeated for sure, it would be 7 days, which is here getting down, getting down, getting down. It will be 3, between 3 and 4 hours, between 3 and 4 hours. And here the model in July, or the most repeated. So let's move to July here. It would be 5 days, which is between 5 hours and 6 H. 5 to 6 H. I think it's clear. Question number C here in the same question for February and July compare. When he say compare in statics, what we do, we have to get the rain, the mode, the mean, the median, which is here I prefer to get the range, or the range here, or the median, which is easy to get it with your eyes. Okay, so let's see here, or an average, maybe. So here in February, we can say that is the most repeated was here 3.5 hours. Okay, but in July was 5, the most repeated 5 to 6 hours. It's clear that is the mode in July is greater than in February. It's logically right. Okay. The model in July, or the most in July is greater than in February. Okay. And here the spread of numbers of hours of the sunshine. Okay, the spread of numbers of hour the most repeated. Here we can say the range here. Can compare between the range. So we can say the range here is the greatest numbers of hours here was 12.5. I can say 12.5, the range. So the range in both July and February. So this would be Feb. This would be July. Here it will be 12.5. minus here the least is 0.5, which equal to 12. And here in Feb, here it is 4.5 minus 0.5. The greatest is 4.5. This is 4.5, the least is 0.5, which equal to 4, which clear that is February, the range of February spread low or lower than in July. So we can say here the numbers of hours, okay. The spread of number of hours in July, in February, okay, less than in July. When I solve statics, I think that I solve English or science. That's actually the statics. Okay, the info is about tally and its heights to the nearest centimeter. Nearest bones, completely clear. When I say nearest, he mean bones without saying higher bone, lower bone. You have to figure it out. To the nearest degree, to the nearest kilogram, to the nearest meter, to the nearest centimeter, whatever he said, nearest. So remember bones, okay? Lower bones and upper bones. Okay, so here calculate the maximum. So he needs the upper bone. You have to figure out, that's mathematics, okay? Possible increase in his height. So we are going to subtract 122, which we are going to get it a higher to nearest centimeter, so it will be 0.5. Okay, we're going to get it higher. Minus, here we're going to get the least. From 116, we're going to get the lower bound, which is 115.5. Okay, so the difference now is equal to 7, which is clear. This we have to get from the first here, we have to get the upper bound. And from the second here, we have to get the lower bound. Why? To make the maximum possible. Okay, that's clear. The diagram shows a graph of y equals 6 plus 2x minus 2x squared. Use the graph to solve 6 minus plus 2x minus 2x squared equal to 0. Use the graph, so we have to use the graph. And many thanks that you already draw it. So that's clear. So we're going to read just the intersection of the graph on the x-axis, which is clear here, negative 1.1.2.3, negative 1.3. First answer here will be negative 1.3. Or real talent that you can read a number from the graph here. It will be 2.1, 0.2, and 2.3, so it will be 2.3. Okay. Put 2 marks in your pocket. Done. Okay, by drawing a suitable straight line on the graph, explain why there is no solution. Why there is no solution for there is no solution to 2x minus 2x squared equal to 3. Actually, 2x minus 2x squared equal to 3. If we can figure it out, we can kick this 2x minus 2x squared and put instead of it 3, which we can say that is y equal to 6 plus 3. So the y equal to 6 plus 3, which equal to 9. And here on the graph, there is no solution for the y equal to 9. So This is clear. This is no solution, say, on the graph. No solution for y equal to 9. And it's clear that from where we get this 9, we kick this equation and put instead of it 3. Again, we kick this equation in the original one, put instead of it 3. So we make 6 plus 3 equal to 9, which equal to the y, the graph itself. Okay, the diagram here, we have a cuboid. In planes of symmetry, we have the planes of symmetry equal to here, the sides of the base, which is 4 sides plus 1. 4 sides plus 1. Because we can cut it like this. We can cut it like this. I mean like this. Here like this. Okay. Or like this. Another one can be like this. Okay. Or like this. I can cut it like this. Okay. Or on the other diagonal like this. Okay. And the last one, I can cut it here like this. So how many symmetrical? It's number of the sides of the base plus 1, which equal to 5. Okay. 1 mark in your pocket. Easy question, very easy. Okay, here he asks you about the theorem show the shaded region defined by 2 inequalities. Okay, and here in this inequality, we shaded, okay. So let's analyze it. Here y is greater than or more than with your eyes. Is it here? Is it y greater, being up, or getting down? Getting down. So for the first one, we're going to choose y less than one of these 4. Okay, A, B, D, or A. One of them, okay? So that is for analyzing. So the first one will be one of these. And here, the y here is this question. Is also, the y here also is getting down. Okay, the y here is getting down. How will I know it's getting down? As x increase, the y is getting down. Okay, that's what I mean by how we know it. So also be one of these. So cancel the first 2. Cancel these 2. We don't need them. Okay, let's figure out how we can solve this. Okay. How about the x-intercept? How about the x-intercept? You know the first step, which make it clear. The x-intercept here, what are the x-intercept here is equal to 1. So plus 1 plus 1. So this one will be A or B. Now we minimize our choices more. We minimize it more. So let's minimize it. So we can say here, the first graph will be A or B because it has a y-intercept of 1. Okay. Is it decreasing or increasing? It is decreasing. The slope. Increase or decrease? The slope here is moving like this. So it is decreasing. So here it have a negative coefficient of x, or a negative number with x coordinates. So it would be equal to A. Okay. So this one will be equal to A. Okay. Let's write this. The second one, which we have to choose from D or A, from D for A because we minimize our choices here. So here we have to choose from D or E. Okay, let's do this. So here we have X, Y intercept with -2, -2A. Here, not 2, -2, Y intercept. So it's clear that is E without moving more for the slope. Without moving again with the slope, it's clear that is the answer here is E because it has a Y-intercept. And again, what is a Y-intercept? The kicking of our linear function or the linear graph here with the Y-axis. With the Y-axis, it is intercept on point -2. Y coordinate -2. Okay, and here is +1. Okay. The table show some expression, the letter A, B, C, okay. Tick the box under each expression, in which could represent an area. Okay, so he needed the one who represent an area, which is squared unit. So in this, he just testing your knowing of is it a cubic unit or a square unit? So it's a square unit. Which is square unit mean centimeter square, kilometer square, okay? But and whatever, it's an area, so we have to multiply two numbers. Okay, here we have A, B, and C, okay? Dividing by D, so we cancel one with one. So the pi is a number, it's not a unit, so we have to mark this as it will be squared because we are going to pick one with one. Here, no, the B multiplied by the C will be cubic. So that's not, you don't have to mark anything because it's not. Here, A plus B multiplying, not adding, no. And here, squared already. And here, it's already also squared and the plus, we don't act with plus. We just need multiplying, so that is already squared. Okay. The next here, question number 11. 1 pictometer, 1 times 12 times 10 all to the power -12. And 1 nanometer, 1 times 10 all to the power -9. Find the number of pictometer in 1 nanometer. Okay. Let's do this. So he needed it changing units, which he clearly write it. So he need here picto to nano. We say 1 picto here is 1 times 10 all to the power -12. And we want to make it 1 times 10 all to the power -9. So we have to multiply here by times 10 all to the power 3 times 10 all to the power 3 or 1 times 10 all to the power 3 just to add 3 power 3. So the power here, -12 plus 3. This 12 plus 3 will equal to -9. So we're going to reach it, the nano, easily. Okay, so here I'm multiplying -12 multiplying by 10 all to the power 3 to give this. Okay, so the answer here, clear. We're going to say in standard form, like he write it. He need your answer instead of 1 times 10 all to the power 3. Okay, the table show the distance in km of some planets from the sunshine, okay? The distance of the planet A is 5.791 times 10 to the power 7. Okay. Which planet is the greatest distance? Greatest distance, which had the greatest power. Here we have power 8. But remember, here some number is written in the standard form. Here 1 point. And some numbers written in 3 digits. So this will be power in the standard form. It will be power also 8. So we have to change them all to a standard form. So that's 5 already. And here 1.082 times here 10 all to the power 8. So that's have a power of 8. And this already did it. And this will be, we add 1 power, 2.279 times 10 to the power 8. And here it will be 7.785 times 10 all to the power 8. I'm just moving the DP 2 places. So I add the power 2. Okay, so this is the greatest, I think, because this is 7. And this is 2, 1, and 5, blah, blah, blah. So this will be it. The distance of planet A from the sun equal to x multiplying by the distance of planet D. Okay. Now, find the value of x for sure. By rounding each case and use 1 SF. Okay, calc can estimate for the value of x. Okay, the distance of planet E. So planet E 7.785. He asked about to write it in 1 SF, so I can kick all of these and write it like instead of 7.7, I can write it number 8 in a 1 SF. So it will be 8 times 10 all to the power 8. Okay, is equal to x multiplying by the distance of planet D, and planet D we can say 2.2 to 2 times 10 all to the power 8. So by dividing both sides here, just to get the value of x, we have to dividing both sides 2 times 10 all to the power 8, just to kick this and remain x. As we do in the right side, we have to do in the left side. So here would be dividing by 2 times 10 to the power 8, kick here. 10 to the power 8 with 10 to the power 8, which is mean 8 dividing by 2, which equal to, or to 1. I think it's clear. Number 12, 2 boxes and 3 cases have a total loss of 335. 5 boxes and 2 cases have a total loss of 370. Each box has a mass of X and each case has a mass of Y. So 2 boxes and 3 cases have a total mass. So 2x, we say mass X, and this is case equal to Y, okay? And will be plus 3 cases, which 3y, equal to 3, 3, 5. And here 5 boxes, which is 5x plus 2y equal to 370.